Hello, this is my physical demo for the digital design project. So I'll start by going over how I came up with the design. So I first realized that I could replace a flip-flop with some gates, and that because I could eliminate a bit. And from there, I came up with a state transition table. I set the counter states, and I went on to K-mapping. From there, I got my Boolean expressions, and then I designed the circuit in multisim. Once I got multisim working, I began prototyping on the breadboard, and uh, and once it worked, it worked. So my design only used six AND gates and one NAND gates, and this is greatly and which resulted in six chips, including the five flip-flops. And this is greatly in part due to some of the simplifications I talked about just now. And in my circuit, I also use color coding ahead of time to make the debugging process a lot easier. So I use the color red for VCC and presets, black for grounds, K for purple for the K inputs, orange for the J inputs, blue for the not Q outputs, green for the Q outputs, and yellow for the clocks. Oh, and I also use the color white for some intermediary results and clears, just because I ran out of wires, colored wires. So obviously I ran into some trouble when designing the circuit on the fit or prototyping the circuit on the breadboard. And this was, first of all, because we were one of the last lab sections that uh, had access to the equipment, and a lot of the equipment was already gone or some even damaged, and we often had trouble not knowing whether we were using damaged or misplaced equipment until we actually tested it. So that was a bit of a problem. And in fact, we didn't realize until the very end that one of the flip-flops we were using was actually broken. And another problem we had was using the much larger combined soldered together breadboards. And this was because we were misconnecting some of the powers and putting some of the powers to grounds when we were bridging the parts of the breadboard, and that caused some issues. So because of these troubles we had to use certain approaches to debugging. And the first thing we did was use a multimeter to see if parts of the circuit were receiving power. And once we confirmed that this was the case, we began checking the wiring for every single flip-flop. And once that was done, we tried changing presets and other parts of the circuit to see the influence on the 7-segment display. And then we began connecting some LEDs to flip-flop outputs to see what would happen. And once we inevitably came to the conclusion that everything we had done was right, uh, we began to think that maybe the equipment was faulty, and that's how we came to the decision to change the flip-flop, which turned out to actually be broken. So in doing so, once we changed that, we got our circuit working, and all and everything uh, every everyone lived happily ever after. So that's it. Thanks for a great semester. I really enjoyed 2E04. Have a nice day.